We're going to solve Leetcode problem number 54, spiral matrix. It's a medium difficulty problem, but it's really not all that hard once you work your way through it. The problem asks us to take a 2D list and traverse it in a spiral order. So here we have the list, 1, 2, 3, 4, 5, 6, 7, 8, 9, and they want us to go from left to right, then top to bottom, then right to left, and work our way around in a spiral fashion. So quick notes after looking at this problem and observing it. I want to traverse a 2D array. I want to change directions at boundaries. And I want to keep going until we see all the values. And let's take a look at a problem to break it down. So here I have a 2D array. And 2D arrays have two sets of indices, so let's write those indices down. We'll call this matrix M. Yep. So the first set of indices, I'll call them the X indices. They start from 0, so we go 0, 1, 2, 3, 4. And for Y, again, we also have 0, 1, 2, 3, 4. So now using these indices, if we wanted to say get this value, we would access it using M for the 0th row and the first or number 1 column, right? Great. All right, so now my approach involves, again, traversing. So first by starting at the top left, making my way all the way over to the left until we've hit a boundary. So here I have this as one boundary. If you go one more step, you're now beyond the bounds of the matrix. So I'm just going to draw in a boundary. Make it purple. Make it thick. All right, cool. So in the next step, I would go down. So as I hit the boundary, I know the direction I'm going to go in. So now I make my way down. And again, once I get here, if I go one more step in this direction, I'm out of bounds. So then I would turn. So let's draw another boundary. Make it green. Perfect. So once I hit the boundary, I then turn. So now I go all the way to the left, once again until I hit another boundary. So let's draw that boundary in. Okay. Now this is where it gets interesting. So I know I'm going to turn, but once I turn, I'm not going to go all the way up to the top, right? So I don't want to revisit 1 because I've already seen it. So what it means now is that as I traverse, my boundary has changed. So let's see what that actually means. So now I'm going to draw in the top boundary as it would have existed right when we started. Right up here. Yeah. And now let's work it back. So remove these, remove these, remove these. All right, so these are my boundaries as when I start. So we have a top boundary, bottom boundary, left, and right. And so when I start in the top left, and I traverse all the way to the right. So now, once I've hit this boundary, meaning that if I go once more, I'm out of bounds, you'll notice that I've finished this first row. So as I finish this first row, it means that I now want to move this boundary down 1. So all I'm going to do is move this down. So now I have a new top boundary. All right. So now I continue traversing. So I know I'm turning here, so I make my way down. So I visit 5, 10, 15, 20, 25. And now you'll notice that I've completed this whole column. So I no longer need to visit anything in this column, so I'm going to move my right boundary over 1. And we just keep going. So now I go this way, so I visit 24, 23, 22, 21, and now I've completed the bottom row, so I just move my bottom boundary up 1, and we just keep going. And now you'll notice, unlike before, when I get to 6, if I go 1 more, I've now crossed that boundary, so my algorithm will stop at 6. And once I've reached 6, you'll notice I've completed this column. So now I just move my left boundary over 1, And we just keep going. The top comes down. Right moves over. Bottom comes up. Left moves to the right. And there you go. So now let me just move the boundaries, get them out of the way. If we look at the path of our lines, you'll notice we followed a pretty nice spiral pattern all the way into the center, and it will work on any size array, so any size 2D matrix. And that's essentially the solution to problem number 54, spiral matrix. You can find a Python solution in the links down below, but that's really it.